And good morning, my fine friends, both feathered and unfeathered. And some with squirrel fur. Yeah? Hang on. Normality shall resume shortly. Oh, okay. The infinite improbability drive has now been disabled. So, or has it just been enabled? I think it may have just been enabled. Okay. I acknowledge the traditional owners of this land, the Whadjuk Noongar peoples. I pay my respects to their elders, past and present, and to Aboriginal elders and peoples from other communities who may be taking part in this live stream today. Welcome, everybody. Stephen W. says, we have normality. Yeah. Moments. Also, TTS is not working right now. I tried to load it and it comes up with a 502 bad gateway error. So, unfortunately, TTS is not running. Is there a squirrel in the room? There are squirrels in the room, Emmy. Which means I have to look through the chat like a caveman. Just moments before the stream, I got a message from Austin saying to consider turning off a thing I've never heard of. Live leaderboards for top fans. What is that? I've never even heard of that. Okay, I'm going to click on this link. The support link of how to disable top fan live leaderboard. Why? What does this leaderboard thing do? Okay, so I've got to go to settings, privacy, live chat, turn off leaderboard. What is this? Is there anything I can do with the experience points I've earned? I don't know. How much is each eligible action worth? What? Okay. Is this just a way of... can you see the crowns? Yes, I can. In the chat, I can see... In fact, I'm going to bring this up. So I'm going to show you what this looks like for me. If I do this, this is the chat window, which is the this is the chat window inside the YouTube Studio interface, which I assume looks pretty much the same as if you're watching the chat just live. And where is this? There. Let's zoom this in. Engagement spam. Engagement, baby. Yeah. Yeah. So, my guess, just based on the 30 seconds of what I have seen of it, is that it's a way that YouTube is trying to make people engage more to generate competition between content creators, so that they try to get people chatting more and doing things so that, yeah, anyway, it's all, yeah, as Crispian says, new feature to cause spam. It's all a way of gamifying this. Oh, yeah, gamification of engagement. Eddie Mills said it just as I was thinking it. Yes. Okay. It's a weird but fun, says Henrik. Okay. It does look the same from my position, says Emmy. Okay, so that is what it looks like. Yeah. Yeah, so there are little crowns with different colours. I don't know why. They cap how much XP you get from commenting in a certain time frame. Wonder if it's 100 points for comments in an hour or 30 minutes maybe. Okay. Encourages unnecessary comments. Yeah, it's a way of getting people to say lots of stuff and do stuff in the chat rather than passively watch. So I understand from their point of view why they have done it, but I can also see how it would be. Yeah, as Tassie Bob is demonstrating right now, I wonder how hard it is to game. Yeah, just lots and lots of comments. You know, I got to turn my mic down a fraction. Coming in hot. Okay, so slightly less hot now. So easy to get more XP, says Johnny. My hot Swedish friend has sent me some sex. 100 of them. Yeah, I don't know the I don't know the exchange rate. I've got no idea what 100 sex is worth. Got me hook, line, and sinker. Yeah, Emmy got sucked in. No passiveness from this end. Fully engaged, says John. Tassie Bob says, I did type this but got rate limited. Yeah. Oh, yes, Mitch says, if there's no TTS, John has to sing the music when Johnny contributes. Okay, I can't even remember the... Oh, click the top fans icon. Ah, up there. All right. So this is... Aha! Johnny is now number 600, at 620 experience points because of the sex. And Stephen is at 300. Imi 275. Crispian at 275. Austin at 100. Yeah, I can see how this would be... Ooh, 100 sec is 15 something Australian dollars. That's a lot. That's a lot. Well, that's very generous, Johnny. Okay. Yeah, as Himi says, they do say sex sells, but you can also use sex to buy things. In this case, Johnny just used sex to buy to buy experience points on YouTube on a new feature that I didn't know existed until approximately 12 minutes ago. That's half a coffee from the local cafe, says David. Yeah, because coffee is 30 bucks a cup here. It's Melbourne. The coffee is worth it. I am periodically going to hit reload on the TTS thing just in case it does seem... Yeah, today's squirrel is YouTube's XP thingy, says Mitch. Now, the thing is... Yeah, how did Austin say to turn this crap off? Okay. There is this link. How the leaderboard works. Oh, yes, I've got to sing for Austin as well. Happy cross an item off the dopamine list today. That is if I don't continue to be distracted by all of this. Yeah, I think I have to do it because it's a channel setting to Braze, and I have to do it globally. I don't think it's something that you can opt out of as a viewer. Stephen says, before you turn it off, how do we cash out our XPs? I don't know. I have no idea. I don't know anything about this, Stephen. If you get @mentioned, you get more XP as well. Ooh, okay. Now, I am going to leave it on for now. I know Austin was annoyed by it and said it was getting out of hand already. XP isn't worth anything, yeah. But I'm going to leave it on just for this stream, and hopefully it won't be a ridiculous, distracting thing, but we will see. We will participate in the great YouTube experiment and see what happens. And if it turns out to be a pain and just gets gamified, or there's no point to it, like what can you even do with the XP? Where is it? Is there anything I can do with the XP points? The top 3 on the leaderboard earn a badge which appears next to their name when they send messages in the chat. During the stream while they hold one of the top 3 positions. Oh, okay. Yeah, that's stupid. It's not like it's even... You don't get anything for it other than like a gold star. So that's what it's about. Now, Michael says, if it turns out to be a pain. If it turns out to be a pain. Hopefully YouTube realizes how stupid it is and relinquishes it. Yeah, okay. If there is nothing that you actually get, Yeah, there is no prize, Henrik. If there was actually some benefit that you got as a viewer from this, maybe I would leave it on. But it looks like, according to this, the only thing you can get, all that happens is the top 3 people with points at any one moment in time, when they send a message, they get the little thingamajigamy, the badge. That's it. Nothing more than that. And it changes live during the stream depending on who has the most points at that point in time. So it's just like a race to see who is in the front of the race at any one moment. Yeah. Oh, Stephen says, encourages more super chats to get lots of points so you can be a winner. Yeah, but even, that's true. But that is if people want to be the winner, which is just getting the little crown thing. And yes, super chats are nice. Super chats keep me caffeinated. But still, I think I am with Austin on this. And what does it say? How to opt out. Go into YouTube, settings, privacy, live chat, toggle off the leaderboard. All right, I'm going into settings. I'm in the YouTube studio. How do I get out of here? No, that's the stream section. I may not even be able to do this.
Hello, hello.
Well, hang on. I got someone at the door. G'day.
Oh, you're on your call.
I'm on a live stream.
I need to pick up the dragon's head today.
Oh, okay. Yeah.
I'll get it later.
Yep.
They're going to paint it.
Mm-hmm.
And Zane's okay with lights.
Okay. Sure.
Just speed the whole process up.
Okay. Okay, so weird thing is I am getting a duplicate stream key error. He's a week late for the barbecue. No. Okay, this is a stupid question, and I know this is but is the stream still live? Because I've just gone into the YouTube studio. I tried to go into settings, and the stream is now saying connect streaming software to go live, as if the stream is not running. So I don't know what is actually happening with the stream right now. You are still live. Yes. Okay, cool. Yeah. Okay, that's good. Thank you. I'm trying to go into settings, and I may kill the stream as it. You're streaming from an hour in the future. Okay. Yeah, Scott can't hear me. Settings. I'm trying to get to the settings without settings channel, because that it is not in this location. Like here it says sign into YouTube, go to settings and select privacy. Live chat. That menu thing does not exist in my YouTube studio interface. So okay, in the interests of just not wasting time with this, I'm going to ignore it and leave it running, because turning it off is going to end up wasting half the stream just trying to figure it out. View in live control room. Okay. Connect streaming software. Okay, I'm back. What? I now have 2 windows with the YouTube studio interface is kind of balked, because I went out of the stream in the studio interface to try to do things, and then went back in, and then I ended up with 2 chats simultaneously. Very weird. All right, here we go. Henrik says, we still hear your beautiful voice. Thank you, Henrik. Okay, so I am going to be pushed for time even without this 18-minute so far squirrel at the start of the stream, I was going to be pushed for time to finish this. I'm going to jump straight into it, because if I don't, I am not going to finish. There is a whole bunch of stuff that has to happen in order for me to assemble these PCBs. So the first thing is I'm going to switch to the overhead camera, because I had to do this. These things, if someone has a better solution to this, I would like to know. These are the BME 680 sensors, that go on the air quality sensor. So it's what is it? Temperature, humidity, barometric pressure, and I don't have it set on. I don't have it as a module on the. I've got to set 25 volts, 8 amps on the power supply. Get the mini hot plate up, and what I'm going to do is steal the BMEs off these modules. I ordered these modules just off AliExpress because it is the cheapest way by far to get BME 680s, which seem to be both hard to buy and very expensive when you can buy them. So I have, because this is a very low volume thing, I'm only making a few AQSs. Also, I went looking for the PCBs and the stencil this morning, and I discovered that I'd panelized them. I have 5 of these, of the BMEs, and I was going to assemble 5 today, but what I'm going to do is just assemble 1 panel of 4. And you can see the footprint just down there for the BME. So I'm going to make 4 AQSs. One of these is going to go to Austin as a thank you for generally being an awesome person, and for the firmware development that he's been doing on the AQS. Maybe I will hang on to 1 myself, put 2 into stock for anybody that wants to buy them. 2024, back when that PCB was revised. And if anybody actually cares about these things. Okay, so the other thing is I've got to figure out how much to charge for these. If anybody really does want to buy one, they're not going to be cheap. There's so much. It's a very simple board, but there is a fair bit of expense in some of the different parts. Like the BME itself, I think these are about $12 each. I'd have to look up my spreadsheet to remember. Oh, Scott says, such a cute little hot plate. Mine is 200 by 200. Ooh, yeah, that's a scary hot plate. Oh, they are already floating away, floating off the PCB. So I can turn that off now. Yeah, this hot plate, it's the MHP 50, which is, many people would be familiar with the MHP 30, the little 30mm hot plate. This is the slightly bigger version, the MHP 50, which is really nice. Which reminds me that yesterday I spent a little bit of time updating some of the links on my gear page, because over time, so for those of you who don't know, there is a page on the Superhouse site. If you go to superhouse.tv/gear, G-E-A-R, it lists various bits of equipment that I use, like the type of microscope I have, my oscilloscope, power supply, soldering irons, multimeters, all of just the miscellaneous stuff. Because I have people from time to time ask me what gear they should buy or what gear I use. So I've got this page called Gear, which has links to sellers. Most of them are AliExpress sellers. And yes, they are affiliate links. So sometimes I get like a couple of % or something as a kickback from a seller. And over time, because the sellers change their ads and things happen, when I went and checked it a couple of days ago, I discovered that almost all of the links on that page were dead. So I have been going through trying to find updated links for all of the different bits of equipment. Let's get that in about the right place. There it is. And updating the page. And so one of the things I haven't yet added is a link to the MHP50, which is this little mini hot plate. Why did that beep? I don't know. I bumped something on it. Oh, I know. It was a it's a tilt error. It's got an accelerometer in it. See how I turned it over? It starts beeping. It's a safety thing, because if the hot plate is hot and it gets knocked over, so it's sitting potentially in a position where it could be melting and burning stuff, it goes into an alarm state. So it's got to be sitting flat for it to be running. So I need to paste that, but first, before I paste that, I'm going to set up the job in OpenPnP. That is, yeah, Henrik says, BME 280 I saw prices like under €2. No, but the 280 and the 680 are totally different. Well, they're not totally different. One is, yeah, the 680 has is a lot much better sensor. The 280 doesn't have, I think the 280 doesn't have barometric pressure. Tabray says most designers would make it so power gets cut to the hot plate. Yeah, it does that as well, I'm pretty sure. It doesn't, if you tip it over, it goes into an alarm state, starts beeping and turns off its power. The display keeps working obviously, but it stops heating the plate. Which actually is part of the Australian standards for selling a heater. If you sell a heater in Australia, it's a legal requirement that if it tips over, it has to turn off. So that's why if you have, you know, those little space heaters with the fan and the heating elements in it that just convert electricity into heat and blow it into the room, they typically have a pin sticking out the bottom, like a little plastic pin, and it goes through into a switch. So if you pick the heater up off the ground or if it falls over, it turns off automatically. And that is part of the Australian standards. Years and years ago, when I was working on the wheelchair hand heater project with Nick and Chris, I actually bought the Australian standard for that's relevant to selling heating devices in Australia. So I can't remember how much I paid. It was like $300 or something to get the full copy of the standard, because we wanted to see what it would take to be compliant with the standard to sell the wheelchair hand heaters. Yeah, Gerald says, DigiKey Canada has an Adafruit module for $31 Canadian. Yeah, those sensors are expensive. Those BME 680s, they didn't used to be that much. A few years ago, like when I was fairly early in the air quality sensor project. What am I doing? I'm talking about stuff when I should be doing and talking at the same time. That would make far more sense. I need to do a go, connect to server, VNC connection to there, bring this up here. Okay. So now we are remoted into KO1. So this is OpenPnP running on KO1, untitled job. Now there are some really annoying things about the way, now can I do this? There is a really annoying thing about the way window management works with the VNC client built into Mac OS. And hopefully it doesn't trip it today. But what I have to do is make this window unnaturally small because it has a window focus problem. If I had this window covering most of the screen Like if I've got it covering, say, to here, and I do something that causes OpenPnP to open a new window, like if I did save job as, I'm not going to click this right now, but if I did this, it would open a save dialog in the background overlapping this window, and I can't select it. Like I can click and you just can't get to it, and because it's a modal dialog, you're stuck. Like if you're controlling a remote machine like this, you are screwed at that point. You can't get out of it. So you then have to physically go to the machine, click the mouse, and then you can bring it to the foreground. But it doesn't happen if the main window is very small. Yeah, Scott says all VNC clients do weird stuff with window management. Yeah, but this is a particular annoying bug. Luckily, the machine that I'm remote controlling is approximately 5 or 6 meters away, no, 7 or 8 meters away from me. And I can just walk over and fix the problem and walk back. But when it keeps happening, when I'm working on the machine, it just pisses me off. So like I'll click something, it'll open a dialog and I'll go, oh, walk to the machine, click the mouse, walk back and keep going. And then it will do it again 3 minutes later. So annoying. So what was I doing? Boards. Let's do new board. New board, create new board. Aha, see? It's done save new board as is ready. It's opened a dialog. The dialog is overlapping. You can see this is jiggling to say there is another window. Let's see if I can click in it. Nope, I can't. I can't get to that window to click in it, even though I made this window really small. So, and I can't select it, I can't pop out the window list from there. I can't do anything. I am now screwed. If this was a remote machine, like a properly remote machine, I would be SOL. And I'd have to get remote hands to go and click on that thing. So I'm just going to walk to the machine. Oh, come on. Click in that window. And walk back again. So now that it's brought that window to the foreground, I should be able to do it. Yes, okay. Now if I go what is this? AQ. Thing is, I've never actually assembled the AQS on pick and place because all of the ones I've done so far have been like one-off prototypes. V41 AQS, V41, yeah, that'll do. Alt tabbing, says Tabraze. Oh, Scott says try minimizing the main window and then bringing it back up. Ooh, I don't think you can because the main window becomes unresponsive as well. Nothing in it that you click actually does nothing. But yeah, I should try clicking on minimize. That is worth trying next time it happens. All right, so now that this has got to that point, I've got AQS board and I want to import placements. Import CADSoft Eagle and browse. Let's turn, yeah, I can't click on anything there now. I can't click on anything there. Oh, hang on, it gave me, hang on, I got the window back. All right, let's see. What am I looking for? I'm looking for this, and then Dropbox, and then Superhouse, projects, AQS, hardware, 4.1 board, open, create, and only on the top of the board, yes, import. So I don't know how I eventually got that window back. I was just annoyedly randomly clicking around at the time. Okay, so now I can do some assignments. What have we got? LED, blue, blue, blue. Yeah, 060310K. That will turn off the BME. Sort by thing here. We've got fiducials here. That's going to be a fiducial. And there are actually remarkably few parts on this. So the TVS diodes, I don't have loaded in feeders. The Vroom, I don't have a feeder for. The buttons, I don't. There aren't, the vertical USB connector, I can't do. That LED, I can't do. The polyfuse, that's it. So it's really just putting down some, Scott says, remote machine was afraid you'd come in and smack it. Yeah, it's really just putting down some quite basic parts. So we've got fiducials for alignment, it's putting down some resistors, some LEDs and some capacitors. It's just the basics, the R's and C's. Now, if I do board, I'm going to minimize this. I'm going to say, no, I'm not going to do that yet. I'm going to queue up all the things that I might have to do. Panels, panels. I think this is going to happen again. I'm going to come in here to panels. I'm going to make this really small. Move that up so I can get to the bottom of the window. Make this really small and see if it then allows the other dialog to work. Panel, create new panel. All right, let's try some key things. I'm going to try Alt-Tab. Nope. Come on, Tab. Nope. And the thing is that these keys have to be passed through VNC as well, so not acting on the local computer. I don't know. How about if I just click on... What was I doing before that made it suddenly come to the foreground? I was randomly clicking and it came up. Austin says, should prep the other parts of the bench before you paste so you don't risk the paste drying out after the machine does its PNP. Yeah, I pretty much have. That's why I was getting those 680s off the donor boards before I do any of the rest of it. Okay, click. And E4. All right. Back to here. And there. Come on. Why can't I click now? What is your problem? Frustration level rising. Click the panels drop down, says Amanda. Yeah, the panels thing there. That's weird. It's like it's locked up. Can I do it from here? I can't even cancel it. It's like the UI has locked up. I can't click on anything. I can't even switch to other things. So I'm on the local computer now. I'll try Alt-Tab got me somewhere else. But I still can't. All right, I can get into here, close that. I can get into a terminal. But if I'm in OpenPnP, oh, let's try going to that window. Oh, hooray, now it works. So annoying. Let's save it in here as Shaw. No, I've got to find all the... What? What just happened? Why did that window just disappear? I need to get a better remote screen sharing thingy. Yeah, sharp panel. Let's see if I can rename that. Sharp panel XML. Back char AQS v4_1. Yeah, that will do. All right, vref control X panel, and I'm gonna do this next part from here, and then go back to my computer after I've done this. So panel definition, children, add existing board. I'm gonna come down to here, and I'm going to panelize that board. I'm gonna make it 2 by 2. At the moment the dimensions are all wrong, but I'll fix that later. Then I'm going to come into the job and do new existing panel and find the one that we just created, which is misnamed. Stupid thing. And then I'll do save job, which should let me char AQS v4_1 job. Yes. Okay. So now we have the job, the board, and the panel all saved, which means I should be safe to go back to my computer. Also, I need to say, Alexa, turn on the air compressor.
Okay.
Tabari said, have you got another input device on the remote machine that's locking the input, e.g. something on the keyboard or a trackpad? It has a keyboard and mouse. It has a keyboard and a trackball plugged into it, which is what I was using when I was standing at the machine. Okay, recenter. I need to recite the litany against fear. Crispian says, an air compressor suddenly started up here. Gerald says, got to go. Oh, thanks for coming along, Gerald. Henrik also asked whether I'd tried TeamViewer software. Yeah, I've used TeamViewer in the past. Does TeamViewer run on Linux? Don't know. I also have some proper remote KVM hardware. But the thing is that machine is running VGA. So, or is it VGA? Yeah, I think it's actually VGA. They're old little compact computers that are running the pick and place machines, and they don't have HDMI outputs. I've got little HDMI dongle-y thingies, which are the devices Bluetooth? Maybe contention issues? Ask John. Don't know. Alistair says, can't you spool up the air compressor as a macro when you start the job? Yes, I could. It needs time to build up pressure though. It's a decent size, it's a moderately big air compressor that is down out like in the factory area. And so if I turned the compressor on when I hit start on the job, it would be too late because it needs air immediately. The very first thing that happens when it starts the job, or if I try to load a board, and the thing is I've got to load a board before I start the job, and it needs air, it needs compressed air just to do that. So the very first operation on the machine needs the air to be ready. Austin says, TeamViewer now requires ongoing licenses and has abandoned customers with perpetual licenses. Don't use them if you can avoid it. Thanks for the insight, Austin. And Jordan says, might try NX for your remote access software. Yeah, okay. Now, I just heard the pitch of the compressor reaching pressure. So it's now up to pressure. So, and turned itself off. What am I doing? That's right, I need to look at the board. I need to figure out the dimensions of the board for panelization purposes, get all the dimensions sorted. It is 58 millimeters. So let's fix the panelization. Panel 1. Oh, hang on. I think I need to where is it? Panels. I was in the wrong place. Okay. Here we go. Panel length. Because I just accepted defaults on the panelization, the offsets are all wrong. So the X offset on here should actually be 58 millimeters. And this one should be 58 millimeters. And the offset on, how high are the boards in the y-axis? They are, what? It looks, I'm trying to measure it and it looks like it's like a ½ millimeter. No, it's 44, they are 44 millimeters high. So the offset for the fourth board in the panel is 44 millimeters. Okay, so we now have 4 boards defined. First board is at 0, 0. Second one is at 58, 0. So that's moved across one to the right. Then we've got one at 58, at 0 offset X. Oh, and yeah, I missed this one. This one should be 44 millimeters. So offset 44 vertically, and the other one is offset 58 and 44. Now, that looks like, me doing this looked like a lot of futzing around. If I had had those dimensions when I had clicked the panelize button and I put the numbers in, it would have calculated everything for me, and I wouldn't have had to do that futzing. So we've got the panel defined, we've got the board defined. If we come into the job, we can see we've got 4 boards. All boards are enabled in the panel. We've got parts. What's the missing feeder for this one? R13. What is R13? And why is it missing? Maybe it's an oddball value. R13, 22K. Why do I have a 22K resistor in this design? I don't remember. Maybe it's just like a pull-up or something, in which case I can just substitute something else like a 15K. I'm going to have a look. Oh yeah, Andrew says I like little jet KVMs. Yes, that's what I have. I have a few jet KVMs. So Andrew says, I like little jet KVMs, works pretty well. Have used cheap VGA to HDMI adapter to connect an old laptop to a projector successfully. Ah, okay. So maybe I could do that. What I would need to do is do a splitter so that I could send the signal to the local monitor and also send it to the jet KVM. I am in the process of opening the design for the AQS because I want to see what that 22K resistor is for, just in case. Oh, and there are 2 22K resistors. They're probably just weak pull-ups that I put somewhere. Let's find out. Here it is. Where are the 22Ks? Let's make this window make a little bit more sense. Value 22K. There's one R13. It's a pull-up on the reset, and the other one is a pull-up on the mode button. Yeah, so who cares what they are? Let's change them. Let's make, instead of a 22K, let's change, oh, I've got to go back into the board. Let's change the 22s to be, I could just make them 10Ks. Let's make them 15s. There's that one and this one. I think I have 15K loaded in a feeder. We're about to find out. Yes, it's happy. It says there's a feeder. So there are 15Ks loaded in the machine. And there's nothing else that's complaining about being disabled, so it's all good. 1 microfarad, it's at 180 degrees. I have this habit that when I'm setting up jobs like this, in fact, I'm going to maximize that now. Now that we're past, hopefully, that painful part, what I do is, if there is a non-polarized part, like a 15K and it's at 180 degrees, I'll just change it to 0 degrees. 1 microfarad there, that can be 0 degrees. What I should do is incorporate this, oh, that's 22, I'll make that 90 degrees. It just reduces the rotation on the nozzle, which can reduce, in some cases, inaccuracies in the placement position. Well, that doesn't matter. That's all the same. Okay, so that's fine. Now, next thing I need to do is, I'm going to hit Save Job, and it shouldn't pop up that dialog again. But now if I do something like open, just as a starting point, I'm going to pull up a recent job. Control TX, spray control, where is one that would have been going through the conveyor? Work buttons doesn't go on the conveyor. Motor does. What I want is just this one will do. The T-Rex MCM. I'm not giving away any special secret stuff here. Minus 143, minus 453, minus 10, 1. 143, 453. Minus 143, panel 1 is at minus 143. I'm just going to do minus 400. We're going to fix all of this in a minute anyway. Minus 400 and minus 10.1 will do. And then there are a couple of things for me to do. But I'm going to do like a dry load before I put paste on the board. So I need to set the conveyor to 99 millimeters should do it, or 98.5. So actuators, set conveyor width 98.5. And in fact, what I'm going to do is, oh, I can't pull that off that off that window. I'm going to open the Reolink client so that we can see the camera feed from inside the machine. Where is the client? Let's go to that, pull up that view. So how am I going to do this? I'm going to move this to be over here so that you can see the machine in the background. And then I'm going to click on set and you'll see, oh hang on, did I even home the machine? Yes, I did. Okay, so I'm going to hit set and you'll see the conveyor move. Boink, there it goes. So the conveyor has adjusted itself to fit the thing. Now I'm going to load the board onto the start of the conveyor. No paste on it yet. This is just to make sure all the basic alignments are done, that everything makes sense. And then we'll paste up the board and let it rip. All right, now I'm going to do load PCB. What will happen when I click this button is you will see that a little pin will rise up in here. That's the stopper pin that locates the end point of the PCB, and then the conveyor will run, it will move the board in, and then it will latch it in place. So I'll hit go on that. The pin will pop up. There it goes. Now the board is moving in, and ka-chunk, it is now latched into place. I could probably do with moving one of those brackets. You can see the top left corner of the board here is not clamped properly. It might be actually a little on the high side in that corner. Michael says, does it create actual ripping sounds? Only when things have gone wrong. So let's move to the top head. Why isn't the top camera working? Or is it just that it's top head? It's the bottom. Yeah, the bottom camera is working. I could see from the light. Let's see. I'm gonna just jog the thing around. No, we're not seeing anything on the top camera. That's annoying. Why can't we see the top camera view? I wonder, no, it wouldn't be a, my guess is, okay, the thing is that the way I would normally fix this with the camera not working is kind of, I'm trying to think of a short way to get this to the point where it's going. What is the quickest path? Machine setup, let's just check the cameras, heads, reference head, camera, that. And we'll make sure that it's got a device selected. Yeah, it's got the UVC camera selected. All the settings are there. Yeah, so there's the HD USB camera. That is the bottom camera. This UVC camera is the top camera. So that should be right. Scott says threaten to go in there to fix it. Yeah, that's it. Machine, I'm going to come in here and fix you. No, what I might do is just in the hope that it'll that it will fix it. All right, save job. I'm going to unload the board. Oops, that's not what I wanted. I want to move this over here. I'm going to park the machine and unload the board. Unload, ba-chunk. I'm going to go and grab the board out of the way so that it's not sitting on the conveyor and the machine can be rehomed. Then I am just going to restart OpenPnP. Oh, actually, while I'm in here, I think I should probably unplug that camera. No, before I unplug the camera, I'm going to quit OpenPnP. Do you want to save? Yes, yes, yes. I'm going to unplug the camera. AV HDMI, I've got to find which one it is. AV HDMI. That one? Yeah. That would be the camera, I think. OpenPnP needs a web interface, says Scott. Does it work? Does it work always, or only when the machine runs? The camera. No, it works as soon as OpenPnP starts. So that view should have been working from the time there we go. See, that is the view that we expected to see. Well, this is good. That means that it was a relatively easy fix. All right, so what I'm going to do, no, I do not want a Java update. What I'm going to do is turn the machine on. I'm going to go through this sequence again, but now it'll be nice and fast. So the machine is now on, it's communicating. I'm going to click home. We will see that it will run the conveyor, or it should. Yeah, so you can't tell, but it's actually running the conveyor right now. Now it's homing the conveyor to find the narrowest point. So it trips its home switch, then it's homing the Z axis, it homes the rotational axis, and then it homes the X and Y. So the machine is now fully homed. So if I now come back into here, I'm just going to do the thing I was doing before, but now we have the upper camera. So 98.5 millimeters on the conveyor, and I'll put it back in place. Oh, I just remembered one other thing I need to do is tell it which fiducials to use, because we've defined the fiducials within the each board, but we need to tell the job which of those fiducials to use. But we'll get to that. What am I doing? Load PCB. On. Loading. And then I'm going to do open recent job. Luckily this does not involve the dialog. We'll do that. We'll transit to the location. Huh, that location was not too bad of a guess. So let's jog it. Over to the edge and down. So what we've got to find is the bottom left origin of the job, and it's there. So let's take it to about there and slightly down. I've only got to get this into approximately the right area. You can see there that the crosshairs are at the bottom left corner of the bottom left board, so that's the 0 point. And I'm now going to just click capture. So this is going to capture that location, those coordinates, as the location of the panel. So that's now saved. So if I now hit park, so I move the machine away from back into its corner, and then I go to the location of that panel, it'll come back to that same location, to within a few fractions of a millimeter. So that's good. We're getting closer. We're getting close to being able to hit the big green play button. So now what I need to do is tell the panel what which fiducials to use out of the board, and then the job inherits that. So I'm just going to do use children's fiducials. The hull only option means the ones that are on outer coordinates. So basically what it does is it hides all of the inners. Because I've got 3 fiducials per board, there are 4 boards in this panel, so there should be 12 fiducials, and it's not showing 12. If I turn that filter off, you'll see that it shows 12 fiducials, but I'm going to turn that filter back on. And the only reason for that is that you want geometrically separated fiducials to get maximum accuracy in the orientation. So I'm going to pick the first one, which is on board 1.1. Then I'll go for board 2.1. Oops, which one is it? Control? Yes, control. Board 2.1 and board 2.2. So that'll give me some geometrically separated fiducials. So now we have 3 fiducials defined, and in fact what I can do is select that. If I go into the job, we've now inherited these fiducials, and I can go to that location. Oh look, it's aligned pretty much. And that one is not so aligned. It's got some twist to the board. And if I go to this one, which will be over the other side, you can see that it's off even more. But that'll all get compensated for by the when we align it for the actual job. It'll take that rotation into account. But that sanity check at least shows that we have the fiducials in approximately the right place, which is very good. And we are now ready, I believe, to paste up the board and to I'm just going to exercise the nozzles a bit. I'm just going to spin it. So I'm spinning the nozzle, spin it back the other way, park it, pick the next nozzle. The reason I do this is that we've noticed that the first board that gets done on the machine on a cold day, the rotation of parts, like placement of parts, can be a bit skewed, and it takes a few rotations, I think, for it to free up. It's actually quite cold in here right now, and if I run this machine, we'll probably find that the placements will be a bit messed up. So park it and go on to nozzle 4, spin that one a couple of times. You can't tell, but the nozzle on the machine is actually spinning when I click that. Spinning at 100 degrees per click, because I've got it set to 100 as the increment. Scott says stiff lubricant. Oh, you can see the googly eyes through this, kinda. Yeah, the camera needs to be slightly more towards the front. Now, that is all, yeah, we're ready to put paste on the board. Let's do paste on the board. Where did I put the stencil? I got it out. Oh, I need a couple of things. I need these. Did I turn them in the right way? No, I got to flip them. Reusing gloves that are, yeah, should be retired. Plenty of holes in these gloves. I may have to get new ones. And where's the stencil? There. So I need the stencil, the squeegee, the knife. Already got the solder paste out. I got that out this morning so that it would have time to warm up nicely. And I've been sitting on it. So the solder paste is nice and gooey. It's a brand new stencil. Yeah, brand new stencil, so it's still got the peely tape on it to protect it. Yeah, I have just been in the process of trying to buy a stencil printer machine. There's someone up in Brisbane or Sydney, I think Brisbane, who is selling a pick and place production line. They've got an IN6 oven, which is the same as Sion's old oven, which I now have, and which way? That way. And they have, they've done something interesting with this stencil. I might chuck it under the microscope and show you in a second. They've got an IN6 oven, they've got a pick and place machine, a Neoden pick and place machine, which is basically the same as mine, but just under the Neoden brand. They've also got an 8 nozzle version of the same machine, a conveyor, a semi-automatic stencil printer, and some other stuff. So I was talking to him about buying his stencil printer, but he's got someone who is thinking about buying the entire production line, every single machine. And that means he would not want to separate out the stencil printer. I'm just trying to find, they've done something interesting and unexpected with the USB-C connection. I've got to get a position where I can get the right angle under it. Where's the aperture for the USB-C connection? What am I looking at there? I'm trying to find where the, oh, maybe it's that way slightly. I've got no context. Oh, okay, now I know, context. So that is the edge of the, oh, the camera is rotated at a weird angle. Yeah, hang on, I'm going to do it this way to be able to find it. I'll use my own eyes. There we go. So this is these are the apertures for the USB-C connector. And what you can see is they've added the little tabs in the middle to prevent paste going down into the holes. and that is not actually what I want. But, oh well, that's just the way it is. So yeah, so the those four large things, the ovals on the corners, those are for the mechanical mounting pins where the stakes on the sides of the connector go down into the PCB to fix it mechanically. And they've added, so this is not in my footprint. My footprint just has those as open spaces, because what I want is that as I put the solder paste over, I want solder paste to be squeezed down into those holes so that they get really firmly bonded. And what they've done is they've closed the holes, or the slots as they actually are, and left exposed just the rim around it. Which in most situations is what you want, but it's not what I wanted in this case. So, oh well, that's okay. It's easy to add extra solder there, or solder paste, whatever whatever I decide is best. Now, where is another panel? I need another one of those AQS panels, because the one I had out is in the machine now. I want this one. And in this, can I be bothered stacking stuff beside it? Yeah, I really should. Okay, I'm going to get a couple of other boards just for a bit of mechanical support and just butt it up against it. There we go, a little bit of mechanical support at least. And now I'm going to probably stick my head in the way. Where, yeah, getting into the ballpark, approximately aligned. The critical part of this is actually the USB-C connectors. These USB-C connectors suck. Sorry, that's my head. I'm going to switch to that view just to avoid sticking the back of my head in front of the camera. Yeah, these USB-C connectors are horrible, but they are vertical mount connectors, and I want vertical mount so that the cable comes out the back of the enclosure. But the result is that the connectors have pads that are entirely underneath the body, and it's impossible to rework them. Once they are on, there is no way to rework those connections. So if the solder does not work properly the first time, you're screwed. Yeah, there's not much you can do. What am I doing? That's right. Now I need gloves. And what else have I got? I've got the squeegee, I've got the knife, I've got the solder paste. These gloves did not invert properly because of the hole. Yeah, well, better than nothing. So while I'm doing this, I am having a lot of trouble paying attention to the chat. Which is that? Oh yeah, I'm just looking for field of view. Yep, okay, so that is where the panel is. And it's sad that TTS is not working, because there is no way that you can get my attention while I'm doing this stuff. Has that covered it? Yep, that covers the y-axis extent of the apertures. Now, did I bump it? Yes, I did. Very annoyingly. All right, back to this view. Let's get the alignment spot on for this. As spot on as I can get it, because I don't want to have failures on those USB-C connectors. Nearly. Yeah, the more effort you put into getting the paste right, the more success you will have with the board. Paste is critical. I had it right and then I slightly bumped it off. Okay, I think that's good enough. Back to this view. And let's go. This paste. Yeah, I didn't quite get the angle right. I'm just going to lightly scrape the top off with the reverse direction on the squeegee. So I'll lift this off and then we will inspect the paste under the microscope. So one of the things, of course, is you only ever scrape it once. You don't go multiple times over. And so that second pass was just to take off the excess. This is looking all right. Oh, the focus is off for the camera because the camera focus is slightly different to the optical focus. I'll fix the focus for the camera, about there. And so there's one of the USB-C connectors. The paste looks okay. Where's it? Another USB-C connector up here. These are the ones that I actually care about. And yeah, that one looks okay. Because if the USB-C connectors are okay, then the rest of the board should be pretty good. So it's looking all right. Yeah, nice. Okay. I think we're ready to put it into the machine. So what I'm going to do is gloveless thumb. Yep. What I'm going to do is unload that board. On. Ba-chunk. Zip. And it's gone. Close that. Alright, so what I will do now is go to the machine, take out the board that's sitting on the exit, put this one onto the entry, and I will come back. And you'll be able to see part of it happen. Alright, so I'm going to pull the board out of the exit side. That's the one I was using for the alignment test. Put the pasted board onto the entry side. And for the rest of it, I should be able to remote drive the machine. So now I'm going to do load PCB. Yes, do it. Join. Joink. There we go. And now we need to align fiducials. So I'm going to select all three of these fiducials and do align and next. So now I've got to jog this. I'm still doing this manually. This is part of the process, and I need to fix the OpenPnP's vision pipeline. Yeah, that's pretty good. This one, not so good. Got to jog it across, bring it down, that'll do. Next one, jog it across. So I'm moving in tenths of a millimeter at this point. Across, yeah, that looks all right. And finish. So we now have the board in and aligned. So if I now go to one of the boards and just pick a random part, like C4, this 1 microfarad capacitor, and I click on go, so it moves to that part, you can see that we are now over the footprint for that part, and it looks pretty well oriented. So I could just pick random parts out of here, drive the machine to it, and they should be oriented. And that's it. So now what I'm going to do This is the bit where it's actually going to be kind of interesting. It's going to go pretty quickly. Like this whole process is probably going to take less than a minute. Where am I? But first I'm going to come back to boards and open the most recent board, this one, and I'm going to select all parts, and you can see that the come on, select all. You can see that the error handling is currently set to alert. What that means is that if it gets an error with any placement, it stops the job and it pops up a dialog until you resolve it. And I don't want that. What I want it to do is move on and accumulate all of the errors so that I can deal with them all in one go at the end. So I've selected all in the job. So now I'm going to, well, why can't I right click here? There we go. Set error handling to defer. So now if we come back to the job, we should be able to run it. I'm going to move it so that you can watch what's going on. Maybe to there, about there. Yeah, that's a good spot. Are we ready? Are we ready? Wait, need to buy me a new heater. All right, here we go. I'm going to hit the play button. It might come up with an error because it's a brand new job. What often happens is if I've screwed up something in the config, I've forgotten to set something, it will come up with an error dialog. If it just immediately springs into action and starts running, then that's a happy day. So let's try it. Oh, here it goes. So it's just picked up an LED and a capacitor and put them down, and you can see the vision alignment. So this window on the right is live. These are the photos that it's taking to do its alignment correction. And then it is putting them down on the board. And you can see on the left view, which is the live external view, you see the flash of white light here each time it moves one of the parts over it. That is a light ring which is being controlled by OpenPnP. So when it wants to do one of the corrections, it turns the light on, takes the photo, and then that photo is what we are seeing in the view on the right here. And you can see the bounding box that it's drawn around it. There is a red box around the part that's been detected. And that's from OpenCV, which is finding the boundary of the part that's on the nozzle and then figuring out if it is offset in X and Y and rotation. And it's going to the back of the machine now to pick up some parts. You can see it's going off to so the front of the machine is to the right in that view, which is where the camera is down here, and the red discard bin. So that red tub there is where it throws parts when there are errors. For example, if it picks up a part and it has too much offset, like it's beyond its threshold of acceptability, or if the part dimensions don't match what it's expecting, it then throws them in that little red tub. So it goes over there and basically does a eject on the part. So that little tub over time ends up with just miscellaneous parts accumulated in it. So how are we going? It's done 52. Oh, it's done. Okay, so what have we got? We have placements 52 of 52. If I look at the panel stats, 52 out of 52. So we had 52 parts placed in 124 seconds. So 1,500 components per hour, which is pretty low as pick and place machines go, but still a whole lot better than me doing it myself. So the next thing is what I'm going to do is I'll move the top camera over the board and then jog it a bit. Jogged it too far. You jogged too hard. Okay. I'm going to move the camera over the board, and then I'm going to unload the PCB, and you'll see that this will unlatch it and drive it to the exit location. and then I'll go and grab it. Ba-chunk, there it goes. Okay, I'm going to go and pick up the PCB off the exit conveyor. And see how embarrassingly bad the placements are. And I am surprised to report that on first inspection it does not look embarrassingly bad at all. In fact, it looks kind of surprisingly remarkably good. Let's find the placement. There's a capacitor. It's a little bit off, but it's all right. There are a couple of resistors. Yeah, that focus is bad. How can I fix that? There. Oh no, it's a resistor and a capacitor. There are a couple more. You can see most things are offset slightly vertically down. Oh, what are those? Oh, those are the transient voltage suppressors. Okay, so those are the TVSs, which I don't actually really care about that much. Yeah, it worked. Let's have a look at an LED and a resistor. So, looks like everything is on the board that is meant to be on the board. So now it is time for manual placement of whatever those extra parts are. I'm going to zoom in a little. Zoom into about, yeah, in fact, why not go for maximum zoom? And then I'm going to adjust the focus. And that'll jump back out again in a moment. So what do I need? Okay, I need the BME 680s, which I prepared earlier. So let's start by putting those on. Now normally I would do this sort of thing under the microscope. Oops. But I want to try to do it in a way that you can see what's going on. Now where is the orientation marker? Okay, so it goes top, left for the orientation marker. Oops. And these. Where's my field of view? Okay, so this is all in view of the camera. Stop it. I'm being very uncoordinated today. And that one. Oh, you know what I didn't do? And I need to go and do this right now before I do anything else, is turn on the reflow oven, because that can take 20 minutes to get up to temperature. Come on, Neoden, let's go. LFG Neoden. Okay. Test, am I on? No, hang on. I'll try reloading the TTS and see if it's still got the bad gateway error. Yeah, still saying bad gateway. So text to speech is not working. All right. So what do I need? Okay, I need transient voltage suppressors, voltage regulator, fuse, S3 module, and I think that's it. That's not too hard. Where did I put them? Here. The stupid little USB connectors. I'm going to put these on last, just because they are annoying, but I'm going to get them out now so they're ready. They're annoying in a few different ways. They're annoying in this context because they stick up from the board, which means which means they get in the way of other parts around them. So they can be the last things on the board. Then I'll grab some, so I'll grab some VREGs. That is, that's a fuse, I believe. I really should check Oh, in fact, before I do that, I'm going to put this solder paste back into the tub and seal the tub, just so that it doesn't get messed up too badly. Got to try to preserve the quality of the paste. I know you can't see what I'm doing right now. This is just off the field of view, but it doesn't matter. All I'm doing is scraping paste off the squeegee back into the tub and sealing the tub. And also I've got to clean the stencil, clean the squeegee. I will do all of that later. That can be deferred. It's more important to get this loaded. So now that we are here, we can do this. Yeah. So I need, what do I need? I've forgotten already. I need fuses. Fuses are here. And I've also got to remember I need 4 of everything. So that's 4 fuses. Then I need 4 voltage regulators, which are right here. And transient voltage suppressors. Actually, I don't know where they are. It's so long since I have used those. Oh, they might be, I have a feeling that they are in, oh, are these the TVSs? Or are these something else entirely? I don't actually even know what these are. NSM, oh no, these are fuses, okay. And I do need those. I need, the tape ripped. How is this sealed closed? Oh, it's that tape. I think this is wrong. I think there's an open one. This is a new reel. There should be other fuses here somewhere. These are, what I'm talking about here are poly fuses. This is a case of me coming into Tom's domain and messing up whatever process he has. No. Okay, I'm going to open this reel. Oh, what's going on there? The cover tape is jammed down the side. That's better. Okay. Oh, it's fuses. Yeah, okay. So that is a new reel of what I had already got out on the other reel, which is on the stand. Yeah, so this should be stored away in incoming stock. It shouldn't be out here. Oh well. What else do I need? Okay, I've got fuses, TVSs. I can actually ignore for now. The thing will work just fine without them. I've got the regulators. Let's stick these on the board and go and remind myself. Oh, that's right, I need S3 modules as well, which is here. I need 4 of these. Ooh, I'm getting low on S3s. Oh, it's S3 minis. I think it is S3 minis on this one. Where are the minis? S3, that's an H2 mini. Oh, there's a whole new pack of, oh no, it's Vrooms. That's different. Where are the S3 minis? That could be, oh here we go, S3 mini. Yep, got them. I need 4 of those. Could have been embarrassing if I had no S3 minis. So I don't normally use those. I designed them into a project for a client, and that client has now used many, many thousands of them. Now, that view. That is the view I want. Okay. Voltage regulators. It is really kind of strange not having the TTS and doing this job, because I'm not looking at the chat. I am even more disconnected than normal. I have not the faintest idea what is going on in chat. If anybody is complaining at me, pointing things out, I just don't know. Don't know if you can hear the sound of the printer in the background. I started a print job this morning. The printer has been running almost continuously for about a week. As soon as it finishes a job, I start it again. It's been printing out PCB trays. So, what's the time? 11:34. I might show you the result of that later. Okay. Yeah, stuff it. I'm going to put the USB sockets on. Oh, there's a cap that is out of place. What's that one doing? It's gone for a walk. Now I've got to fit on the Vroom Minis. And oh, I just realized we're going to have about 6 minutes while this is going through the oven. So I can catch up on chat then and show you other things. Put that on there. Yeah, if I can find the TVSs, I'm going to put them on. I will have one more quick look. The TVSs go on here and here. Fuses, they're probably in the fuse box. No, I don't know where they are. They're around somewhere. Tom will know where they are, 100% guaranteed, because he's the one who puts them onto boards. We use them on water cannon control boards, so we do go through quite a few of them. They will be there, I just don't know where they are. Oh, I just noticed there's a missing LED up here, just there. What color is that LED? That'll be a blue. Do I have blue LEDs? No, I do not. Okay, I'm going to put on a green LED. Do I have green LEDs? No, I do not. I'm going to put on a red LED. My guess is that what happened is the pick and place machine put it on and then it got knocked when, yeah, it probably wasn't properly adhered to the paste in the board, and I picked the board up and moved it around and it probably fell off somewhere. Everything. I think that is everything. All right. Now, I don't have a camera in that particular part of the room, but I'm just going to, I will take this in. Also, I don't know if the reflow oven is up to temperature yet. It's not. It's not even close. 141, 184, 168. And it is pulling 1800 watts. Okay, so it's in its warm-up phase. Well, I suppose that gives me another another little bit of time to look for TVS diodes. They will be here somewhere. EPROMs, Hall effect sensors, temperature sensors, more EPROMs, but not TVSs. Not there. Yeah. Transistors. No. It's possible it's in the semiconductors box, which is here. Possible, but not likely. Yeah, screw it. I'm gonna look. Break the seal. Diodes, what have we got? MMD 914s. Oh, that is an entire reel of that is actually what I want. These are the transient voltage suppressors. I just realized they're probably in the machine. I could have had them put on by a pick and place machine. Let's see. Are they in here? They're not in any of those feeders. Maybe in one of the back feeders. TVS. That could be why I couldn't find them on the bench. PGB, yeah, there they are. PGB 1010603s. Okay, that means I can, unluckily, it's in a new feeder, which means that I can manually advance it. The old style feeders were terrible in that respect. You couldn't manually advance them without a whole lot of trouble. So, let's grab some out of here. Picking stuff up out of feeders is still annoying because there's not much room to get the tweezers in. Can't get this one out. Oh, got one. Okay. Where am I going to put them? In my hand. Okay. Sorry, I'm going to have to just kind of focus on this for a moment. Getting these out. While you're just staring at my back leaning into the machine. This was silly. I should have realised that these were loaded in the machine and set it up in the job. And then it would have just been put down with all the other parts. I just tried to pick one up and it vanished. Like it went sproing. It's the classic thing when you're dealing with surface mount parts is if you flick them the wrong way, it's not like you even see them fly off. They just vanish. It's like they cease to exist. They teleport out of existence. Okay, it's 5. And yeah, so that other TVS is now somewhere inside the machine. I need to vacuum in the machine periodically just to get all of the loose parts because they do come off occasionally. End up in random places, like they fall off nozzles or they don't get picked up properly, and then as the feeder advances they get dumped out into the insides of the machine. Oh, I left the board in there. Come on, Eden, you can get there. Oh, it's getting close. It's up to 210 degrees on the spike zone. Okay. transient voltage suppressor time. What's the time? 11:42. I think we're just barely going to make it within the 2 hours. By the time I might end up running overtime. I don't know. Oop. Come on, turn over. By the time the 6 to 7 minutes of the reflow process runs, once the machine has got up to temperature, that will pretty much bring us to 12 o'clock. And then I still need to put on the manually added parts, like the header for the where is it? Here, the header for the particulate matter sensor, the buttons, the header for the display, flash firmware onto them. There's a bit to do after that. Running them through reflow is not the last step in the process. Okay, so these are now ready for reflow. Awesome. So back to, where am I back to? Back to here. See the part when he places the button. Okay, I don't know what that's about. All right, he'll have a moment of panic seeing the discussion of that part while it's in the oven. Should upgrade to a, you might see error message and see the note about the, okay. I am looking at chat, but I'm not going to bother catching up with everything. Waiting to help you hear the machine yell, ouch. It's 11:45, isn't it? Someone just said my clock is slow. There's a guy, Stephen says, there's a guy loading $50 notes seemingly endlessly into a Bitcoin ATM here. Whew. Jordan just said something that I have actually thought about as well. Jordan said, is it reflow if it's the first time? I agree with you 100%. In fact, when I first started learning about reflow, that question actually came into my head, like, why, it should be just flow, not reflow. Oh, Matt W said first flow is applying the paste. Oh, yeah. Oh, Simon said exciting but busy week with sats launching. Nice. You got some satellites going up this week? For those of you who don't know, Simon works in aerospace stuff and puts things into orbit, which is very, very cool. Stephen said the solder balls in the solder was probably flowed in its manufacture. Yeah, it would have been. So there are a few ways that you could creatively interpret it, that the reflow is actually the second flow of something, either the flow of the paste or the flow of the solder to make the solder balls. But in any case, it still seems stupid that we're flowing this solder on for the first time. We are not reflowing the solder. Simon, yeah, the stress is real. Yes. The anxiety associated with high stakes engineering with no second chances. Yeah, that's not fun. Wagon Loads asks, can you make a PnP machine place parts by manual remote like they do robotic surgery? Yeah, I could do that. I can drive the machine totally remotely. So I could do, for example, I'm not actually going to do this, but, well, maybe I could. Yeah, screw it. I'm going to do this. All right, now, imagine, now it is laborious. You could do this, but I wouldn't bother. So, imagine you had a location. I'm going to jog the machine manually. So I'm going to go to, while this is happening, whoops, can't move down there. Okay, yes, of course it can't. Oh, I don't know if you heard it. the reflow oven just played its little musical song, which means it's ready, it's at temperature. I'm gonna, oops, gotta take the panel with me. So I'm gonna put the panel in the reflow oven, which will then give us a few minutes to do some not recommended stuff with the pick and place machine. Okay. Now, imagine we had a location. I'm going to go left, and then can I go this way one? Okay, so what you're looking at now, this video, the down camera, is looking at the discard bin. So that's stuff that it has thrown into that little discard area. In fact, if I move this like this, do this, and change, we'll get a third-party view as well. So now you can see that the top camera is looking down at that red tub. The focus is all off because the tub is below the focal point of the camera. It's designed to focus at the surface of the PCB. And this tub is down low. So that's why it's out of focus. Anyway, imagine we had a PCB and we wanted to put a part there. Say it was something like a 1K resistor. So if we go to parts, here we have a 1K resistor. What I can do is click this button, which is perform a feed and pick of the selected part from the first available feeder. So I'm going to move this view just over to here so that you can see everything happening all at once. And I'm going to tell it to pick up a 1K resistor, and it will go and grab one. Here it goes. There we go. So it has now picked up a 1K resistor. It's holding it just above the feeder that it picked it up from. And now what I could do is go to bottom vision for that 1K resistor. I mean, you probably wouldn't bother doing this, but if I go to, let's see if I scroll this, and see the test alignment button, I'm going to click test alignment, and you will see it move over the camera and take a picture, and it has now just done the alignment correction. So if I click it again, I can keep clicking this. What this has done is it's just updated its own knowledge of the position and orientation of that part each time I do that. So now I could put that part down extremely accurately at any location that I want. So if I, for example, switched to this camera view, the top camera, and I wanted to put it down at a certain location, I'm going to move over here and here. No, I want the top camera view. See, if I wanted to put it right there and I was pointing at a destination, you can tell OpenPnP to substitute the coordinates of the nozzle and the camera. So you can tell it, for example, I am looking at this exact location with the camera where the crosshairs are right now. I want you to put the nozzle at that location. So if I now click on now I'm going to do this, I've got to go back to the job control panel, and now see this button here, which is position the tool at the board's location, and this is position the camera at the next board's location. Where are we? Set the board. I've got to find, I don't normally do this, so I've got to find it. Nozzle. Oh, okay, I've got to find a placement. Maybe, yeah, I'm sure there's a way to switch it. Is it there? Switch. Oh yeah, move camera to position of selected tool. Move last selected tool to camera position. Oh, there we go. Okay, it's over here. This is an oddball way of doing it. So if I select, oh, it's not going to let me. I can move the camera to the tool's position, but I can't move the tool to the camera's position. All right. Maybe this was a stupid quest. Position the tool at the board's location. I don't want to position the camera at the boards. I don't want to do it to the board's location. I want it to do it to the placement's location. So if I had this placement, I could now position the tool. Nah, stuff it. I'm just screwing around here. This is a this is a silly thing to try to achieve. I'm sure I could do it with a bit of figuring out. I could make the nozzle drive to the location of the camera. But for now, I'm just going to throw it away. So what I'm going to do is hit discard, and that is going to zero the Z-axis, move the part over the little red discard bin, and then throw the part away. So I'll click that now. There we go. So it's just throwing the part in the bin. Then I'll park the machine. Okay. Can I see the board? No, I'm just looking into the oven. Oh, the board is about 2/3 of the way through the oven at the moment. If I look down the slot, I can see it coming out towards me. And the 3D printer has also just finished. So while I am waiting for the thing to come out, machine is telling you you're a dummy for trying to place it in the bin. Yeah. Should have stuck a board in for the full experience. Yep. Stephen W says, I can't believe John is wasting fractions of a cent to show us how manual placement works. Yeah, manual placement, not that useful. Okay. I am going to grab this and show you what I have been printing over the space of the last week. Ta-da! Which reminds me, this morning I got a message from someone. Is Amanda here in the chat? I don't think I remember seeing Amanda. So that is a PCB tray. Yeah, so now this can go in and make another one. I have printed many PCB trays over the last week. So this one is for boards that have passed testing. So what I've got PCB trays in 60, 80 and 100 millimeter widths. They have 16 slots per tray, and when a board has just gone through, when it's gone through the oven and it doesn't have extra parts on it, then you basically have one board per slot, so you can fit 16 on it. And then often after boards have had extra parts put on them, so that when they've gone through the next stage, they might have big capacitors or some switches or something added to them, connectors, then often it'll be every second slot. So there will be 8 PCBs per tray. So I have these in colors for the different parts of the process. The board is just about to come out of the oven, but while that is happening, I'm just going to grab a couple more trays to show you some different things. Oh, and blue ones are assembled. Where do I have one of those? Oh yeah, this will do. This tray has actual boards in it. So I have trays in 4 different colors. So 3 widths, 4 colors. So 12 variations. I've got, that was the sound of the thing coming out of the oven. Yellow are ones that have just been through a reflow. And then after, so yellow ones end up with trays of boards that don't yet have parts manually added to them. Then once they've had things like this is assembled, it goes into a blue tray. This has had things like a fuse holder soldered on. There's a MOV that's been soldered on, so the through-hole parts have been added. So it goes blue. Once they're in the blue tray, they're ready for testing. Then when they are flashed and tested, they go into either a red or a green tray. You can see two different widths here, so 60mm and 80mm trays. So they either go failed or passed, depending on what happens with testing. The failed ones loop back for rework. The passed ones go for packaging and dispatch. And there are many of those trays now around the place. Wagonload says, I thought manual placement could drive the part to the exact location on the PCB. Yeah, it can. You can put in a coordinate. Like if I switch back to, if I come over here and show you this. So we've got we can drive the this to an exact location. So it's a little bit hard for you to see, but there's a DRO, a digital readout, right down the bottom of the screen here. See, it's got X is -10, Y is -10, Z is 0, C is 0.396. That is the current location of the selected tool, which in this case is the camera. So if I go to nozzle 1 and then bring this back across, you'll see, oops, can I bring that up? Yep. You'll see that nozzle 1 is currently at -42.85mm, Y of -60.1, Z of -1mm, rotation is -1080 degrees. So we've got, and we can drive down to 1/100th of a millimeter increments here in the interface. So you can accurately drive you can drive any of the nozzles, any of the nozzle tips rather, to accurate positions anywhere within the envelope of the machine. So yes, you could manually drive it to an exact location, but it's just a waste of time. Just define a job with all its placements, hit the big play button, and let it do its thing far faster and less error prone than a human could do it. It's not worth trying to drive it manually. That would be silly. All right, just turned off the reflow oven so it can cool down. And let's do ourselves a little bit of manual inspectionalizing. Yeah, these are the, the trays. Multicolor printing is so cool. All right. And here is the panel. I will put this under the microscope because we can't really tell very much from just looking at this. I'll pull those placement caps off, and microscope time. Let's see what we've got. So methodically, starting from the top left of the board, working across, LED resistor. So what I'm looking for here is either tombstones or parts that have not flowed at one end or the other. So sometimes you can have a part that is connected, it's sitting flat so it hasn't tombstoned, but it's not sitting where it should be. Or it has one end that is floating up. And in fact, it looks like this LED may have this problem. It might be fine, but just from the angle that I'm looking at, it appears to me, I've got to try to fix this focus. Yeah, that's kind of okay. It appears to me that even though it's sitting flat, this end of the LED may not have properly flowed. So there might be it might work, it might not, but just for the sake of making sure that it's fine, I am just going to touch up that joint. So just manually flow a little solder into there, and then everything should be happy. Okay, moving along. This looks okay. What I'd really like is one of the multi-color, what do they call it? Collinear lighting systems that shows the curvature, like the fillet, on all of those Yeah, so apart from that, everything looks fine. So I think we have 4 good boards. Now what I'm going to do is pull the microscope off the edge of the bench and see if I can look underneath. So what I'm doing here is looking underneath the connector, and you see where the pins are there? That is the area where the contacts go onto the PCB, and that's what I mean about these headers being horrible, because there is just no way you can get a soldering iron in there. It's got stuff in the way. It's like those little pins are in prison, in jail. They're obscured. So if you get a solder bridge or something in there, you really have to use hot air, or yeah, that's pretty much the only way you could do it. The only way that you could rework those connectors. So you need to make sure that the solder paste application is good, so that you don't have any open joints and you don't have any bridges. But as far as I can see on those connectors, they all look good. So I'm happy with that. Doing that with the stencil seems to have been effective. So now it is time to split these apart. I want to make a board splitter. I bought parts to make a board splitter. Top and bottom wheels that are aligned like pizza cutting blades, but tougher. And now I've got to split this. Do it gently, work it backwards and forwards so that it doesn't stress the solder joints. Normally I do this on the edge of a flat bench so that it's supported right up to the point of the bend, because I don't want to make the PCBs themselves bend. They need to stay perfectly flat so that it doesn't stress any of the solder joints. So the way I'm doing this now, I'm only doing it like this so that it's in the camera view. This is not how I would normally do it. Okay, and now we have 4 separate boards. There. Alrighty. What next? What next? I suppose I could try flashing them, but there's not much point doing that yet because we don't have the display, we don't have the connector on for the PMS 7003. Although what I'll do is I'm just going to plug in USB just to power it up and see if we get the power LED coming on for each one. No. What about the other way around? No. Let's try this one. Yeah, okay, so this power LED comes on. You can, oh, this is the red one. I wonder if the LED is backwards or something stupid on this, or if there is some other problem going on. Doesn't look like it. The circuit looks okay. Yeah, I don't know what the issue is with that. Let's just try this one. See if we get, yep, we get a blue LED with that one. I'll turn the cable around just to check both sides of the USB connector. Yep, LED is coming on. Try the other way. Yep, okay. I'm going to add some solder onto these connectors because the hole was masked off. You can see that on the back of the connector here, this is where those mechanical mounting stakes come through the PCB, and that's where I wanted all of the solder to be mechanically fixing this, because these connectors stick up, I'll do it this way so it's in focus. These connectors stick up a long way from the PCB, and they can take a lot of lateral force, and we don't want all of that stress on the pins. So the supporting stakes on the side need to be well soldered to stop them from flexing around. So I am just going to do that manually under the microscope. But first, Alexa, turn off the air compressor.
Okay.
I just heard the air compressor running and realised I hadn't turned it off after finishing the job. So this will make the connectors much stronger. I always worry about vertical connectors because they put so much strain on at the location of the pins. But yeah, that feels really solid. Okay, I'm going to do these three. So we've got one board where the power LED didn't come on, and I don't know why that is. I need to do some diagnostics. It could be a problem with the connector. It could be something on the board itself, like with the voltage regulator. The 5 volts that's coming in from the USB connection is going into the 3.3 volt linear regulator, which you can see right there. So it could be a problem with the regulator. I'll need to do some probing on the other board to figure out what's going on. But I'll circle back to that. In the meantime, I'm just going to make some progress on these three, because my plan by the end of today is to have these fully assembled and ready to ship, which won't happen on the stream because there's still a fair bit to do. Yep. Now I need the PMS. Oh, buttons. I need to figure out what size to do for the buttons as well. Let's have a look at that. Somewhere. Where did I put it? There is a box here for the project, and I've got the enclosure. So this is an enclosure that I printed previously. And normally what would happen is that this would fit into the back, so there would be a display and the particulate matter sensor mounted on there. This goes into here, and then this goes on the back, and you can see it's got these little spacer standoffs that push down on the PCB. So it goes around this way, drops over the USB-C header, which sticks out the back of the board, and screws on. So these two holes here, there and there, are for the mode button and the reset button. So I need to find the appropriate size buttons to make the stalks come out through that so that they can be pressed. 4.5, it's going to be let's check how far down that is to the PCB face. It is 6 millimeters from the flush back surface to the PCB. So I am going to go for a little walk and look for 4.5 millimeter buttons. Oh, they're out in the factory. They're in the mechanical area, in the swamp. So I've got to go and check in the swamp for the appropriate length buttons. I want one that's going to come to approximately the face of the thing, so that it can act as a reset button and not be too easy to press, and the other one to actually protrude out through it. So I think I need a 6 millimeter, and then I'm going to go for something like a 7 millimeter. Yeah, this will do. A 6 and a 7. So the 7 will protrude 1 millimeter out the back. The 6 should end up approximately flush with the surface. And here they are. So if I put a 7 on the mode button and a 6 millimeter on the reset button, and put it back in. Obviously they need to be soldered, but this is just a fit test. Put that back in there. So now the mode button just protrudes slightly. You can press it with your finger. The reset button is kind of flush. So you need to press it with something, like a pen or whatever. You can't quite press it with your finger. So I think that's about right. So I think 6 and 7 millimeter buttons, if you look down vertically there, you can just see the black button there. You can't quite see the black button there. Oh, Wagon Load says, are the green SMD parts next to the USB the 5.1K resistors? No. Yeah, those are the transient voltage suppressors. The 5.1K resistors are there and there. That focus is wrong at that distance. Easier to see it here. Yeah, these two are the transient voltage suppressors, which are on the data lines. That one and that one are the 5K1 resistors, which set the charge current. So they're on CC1 and CC2 going to the connector. Okay. I might as well solder those switches in while I'm here. And then I can do the, stinky with no fume extractor. And then I can do, what am I going to do next? I will do the connector for the, yes, I'll have to do that. Or do I have to do that? I don't think the order matters. Works either way. My stomach just rumbled at me. I'm sure there are people already in the chat who are reminding me that it's lunchtime, but because I can't actually see the chat at the moment, I've been relying on my own biological processes to give me that feedback. All right, switches are in. Then I could put the connector on for that. I need a connector on there for that. I think I am going to, what am I going to do? I think what I'm going to do is take one of these through to assembled completion. Not all of them, just one. It's already 12:15, but I want one to be complete in its box so that you can see the end result. And then, after I've had lunch, I will continue with assembly off stream, because it's just a task. So there's a display for one of them. In fact, I'll get out the displays for all four now. I'm just not going to bother doing all four of them on the stream. Here are the particulate matter sensors, and these are the sockets that need to go on. So I'll need 4 particulate matter sensors, assuming that I managed to get the other one working. Oh, Wagon Load says, screw the lid to the PCB so it aligns the buttons while you solder. Oh yeah, that's true. I could do that. That's a clever idea. I don't think it's necessary though. What I did was I soldered one corner of each, and then where am I? Just moving stuff out of the way. Okay, where's the one with the buttons? This is the most complete one, so this is the one that I will bring to completion now. Yeah, I soldered one corner of the button, and then I pushed down on it with my fingernail while reflowing that solder so that it sat flat on the PCB and it's all perfectly aligned. So I won't have any alignment problems now. If I chuck it in the enclosure, chuck that on, works perfectly. Buttons are aligned very nicely. Connector comes out the back. So that's good success so far. All right, I'm going to solder on the connector for the PMS, which is, I think they're 1.27 millimeter pitch. So they're pretty tight. In fact, what I'm going to do is just do one of them here, and then I'm going to chuck it under the microscope and do the rest of the joints, because I want to make sure it's good and all straight and nicely aligned. Yeah, I do most things under the microscope. Why strain my eyes when I can do this like this and be able to see everything? And see properly. I'm not trying to drag solder with this because these fine pitch connectors can be a little bit problematic. And also I'm trying to minimize the heat exposure. Okay. Connector is in place. So I could plug one of these in now. I'm not actually going to leave this plugged in, but that plugs into place. And then when I do the actual assembly on this, I'm either going to put some double-sided tape in between so that this stays attached to the PCB, or maybe put like just a little dob of glue on each side. And I think that's what I'm going to do. I'll use some of the Loctite extreme gel glue, which is what I use for mechanical stabilization of parts that are going to be subject to shock. It's specifically designed for that sort of application, so I'll put a little dob on each side, but for now I'm going to carefully unplug the particulate matter sensor and go back to this. Oh no, I need the PMS in place for the positioning of this, but what do I need? I need a 7-pin. Hang on, why does that not match? I think these are the wrong displays. I got out the wrong ones. Where's the box? It should be an 8-pin display. Well, here's one on a different thing. These are the same displays that are used in the Rack 32 setups. So I'm just going to reuse this one that was on an older prototype. So in fact, this is what is this? Where's the version number? I can't see it. Is it on this side of the board? Nope. This is one of the older ones. It's got a CP2102N USB to serial adapter on it. Anyway, doesn't matter. I'm going to put that one away. I'll just use this display from it. I think the other displays that I've got are probably in a box for the Rack 32, and I'm not going to go hunting right now. I will do that later. So for now, I will put this display on. So I need an 8-way stacking header. There's probably one in here somewhere. That looks like one. Because I need to space it off the PCB. This header needs to be artificially elevated to allow the display to be in the correct position. Oh, it's got tape on it. Oh, that doesn't matter. It's not going to get in the way. To be in the correct position to clear the PMS. So what I need to do is plug in the PMS again. I should have just left it in before. Plug the connector into the display and then put the display in position, and that gets the spacing correct, because looking down from here, the display sits on top of the PMS and the connector it doesn't sit flush down here. It's spaced out a little bit. So what I'm going to do is just sit it like this, hit it with some solder on one of those joints, and then I can make adjustments if necessary. So let's just pick one and check the alignment. Make sure that everything is straight and square. looks good to me. But before I do that, I'm going to drop it into the box before going any further and make sure everything does sit down properly. Yeah, the display is pushed against the front. That sits flat. That's like it's a perfect fit. In fact, what I can do is use this. This would be the sensible thing. Use this as the thing to hold it while I solder these in place. And then I can cut the pins off. Yeah, this PCB doesn't screw into the enclosure separately. It's retained by the back cover. And the back cover has those little standoffs designed into it that come down around the screw locations and push. Okay, so take that back out so that I can cut the pins. I'm also going to remove the protective film off the screen because it comes with this film on it. And maybe I don't even need the glue on here because it all stacks so nicely inside the enclosure. It all compresses perfectly. I don't think the sensor can actually come off, like it can't move. Yeah, oh, it's a thing of beauty. And the holes there allow access to the vents on the PMS. That screws on. Yeah, I'd need to go and grab some screws to actually put that on. Well, and then it sits on the bench like that. I really like this color. I love the yellow. It's like a deep golden yellow, not a washed out, horrible looking yellow. Yeah, that's it. Apart from firmware and screwing it closed, that's actually now 100% assembled. So, we're kind of done. We're kind of, I think, are we kind of done? Let's see. Wayne says, your picture is hiding what you're doing half the time. Yeah, the field of view on the camera, the overhead camera, is further left than I think it is. So when I'm working at the bench, I'm sitting there square onto the what I'm doing, but the camera is actually to my left. And so it's looking down beside what I'm doing. I need to have some markers or something on the bench that show the field of view of the overhead camera so that I know when I'm in the frame. But yeah, we have it. Apart from loading firmware and testing it, this is now 100% done. Michael Wise says Pikachu. Yeah, I think that's the color, isn't it? Is that what you're referring to? The Pikachu color? Crispian says, on-site director and camera crew would help. You're right. Yeah, so I just need a director, a producer, a camera operator, like a Foley person for doing sound effects. I need a grip for microphones. I need, most importantly, a catering officer. A gaffer, says Austin. Yep, a gaffer for making sure microphones and things are right. Yeah. No, this is not exactly the world's biggest production. Okay, so we now have a complete air quality sensor. I just need to do those last couple of steps for the other ones and figure out why one of them didn't. Yeah, Stephen W says tape a box just outside the camera view at the lowest zoom level. If you center yourself on that box, you should be in the middle of it. Yes. I actually did have that previously. So on my bench, if I'm going to zoom this camera right out to maximum unzoom and switch to the overhead view. So this is the overhead view camera again. And there's I'll just move these. You can see right here, this is the edge of a piece of static dissipative material. So the whole bench is covered in it. And then I've got a rectangular piece that is cut that sits on top of the bench, because I end up messing this one up. You can see it gets burn marks and solder and flux and things over time. And I didn't want to have to replace the entire bench surface. So I have a piece of this sitting on top of the bench, which means I can dispose of it and put a new one down. And the previous piece that I had here, I actually had some blue sticky tape on it. So what I did was, my left hand now is coming just to the edge of the field of view, right hand just to the edge of the field of view, and I had tape on the surface so that I knew where the field of view was, and that I knew that it was a box that was that size. And then I ended up replacing the top, and I didn't put tape back on it. So yeah, that is something that I need to do. Okay. I'm going to go, mostly because I'm hungry. I really need to eat. Some Call It Fun says, we can only see to just right of that power cable. Yeah. So the Stephen's comment about doing it at lowest zoom level is correct. So the idea is that with the camera as far zoomed out as possible, you do the bounding box, and then as you zoom in, it'll be centered on that box. So as long as I'm working in the middle of that box, I know that it'll be in the center of the camera view. Jordan asked, does the second layer pass ground down to the first layer? Kinda. The material is static dissipative. It's a layer of static dissipative material on top of another layer. The layer that's on the bench has a ground connection on it, so that will dissipate, and the top layer of material has carbon impregnated across the bottom of it, so that if you have static, static shouldn't be able to build up on the top surface, because it will be slowly conducted away through quite a high impedance through to the carbon layer on the bottom, which will then be wicked away through the bench surface. So the top piece, the sacrificial piece that I work on, is not explicitly connected to ground. It probably should be. What I could do is I could add a strap that goes to that piece in particular, but because it's sitting on top of another piece which is explicitly connected to ground, I don't think there is any static problem. It should be okay. Yeah, so I'm gonna go and eat, and then I'm gonna finish making these AQSs. Then I'm going to figure out how much I've got to charge for them to make this all worth my while and make them available on the site. And I'm also going to print cases in a few different colors so that I can send them to Austin, and he can he can pick what color he wants depending on his mood. Yeah. Jordan says, yeah, I wasn't sure if the dissipative surface went all the way through. Yeah, that would actually be an interesting experiment, like to stack several layers of it, because I've got pieces of it around the place, offcuts. Stack a few layers of it and measure discharge through it. Lachlan has the test gear that's used for, you know, the test and tag stuff. He's got the gear that generates the high voltage and measures leakage, like he can measure earth leakage and all of those sorts of things. He's got all of the test gear required for it. So what we could do is have a single piece and stack multiple pieces and measure the leakage through it and expose it to like the high voltage test signal and see what happens. That'd be an interesting thing to do. Okay. Austin pointed out, I'll get back to updating code once my current project is complete. Yeah, so the code for the air quality sensor that Austin has written, as far as I'm concerned, it's functional. Like I'm actually quite happy with it as it is now. It works very well. it displayed, I'm just wondering where it is. Where is my AQS? It may actually be at home. I can't remember where it is. I've been bringing it to and from, like between home and here. I think it is actually at home at the moment. It displays useful information on the screen. It changes color when thresholds are exceeded. It's got MQTT reporting. It's configurable. It does all the things. There are a couple of little tweaks that would be nice, like sleeping the sensor when it's not using it. But those are tweaks. It's, as it is, it's far better than I would have ever managed to produce. So thank you, Austin. And I really appreciate all your hard work on the firmware for that, particularly considering you didn't even have the hardware. So that's really cool that you created something that works. And I very much appreciate all of your expertise and effort on that. And I will get you an actual AQS. Now that I have the real ready to ship hardware, I will send you one. So yes, and as Austin said, also it's an item off the dopamine list. Yeah. So as far as I'm concerned now, in fact, let's do this. Before I go, this is going to be the very last thing. I'm going to pull up a spreadsheet and put it on the screen. View actual size and move this up here and go to here. No, I do not want to uncover deeper data insights with AI. Go away. Screw you. And where am I going? All right, let's go 150%. So, this is kind of a big moment because the where are we? Air quality sensor. So, assemble V4.1 boards. That is what I have just done. Revise the enclosure. That is done. Discuss firmware with Austin. Austin was on the stream and went through the firmware. That is done. Make some. Well, that is what I'm doing right now. So I've just made the first one. I'm going to call that one done as well. So that means that I can now take the air quality sensor and drag it down to the done section. In fact, I'm going to make done green, and I'm going to make mech area lighting. Do it. That's done. I'm going to make all of these green just for the extra little dose of dopamine. So the greenness is the space of satisfaction, completion. So there is going to be more stuff to do with the air quality sensor. Projects are never actually done, but it is done to the extent that I can now put it out of my mind a little bit. I just need to list them up on the site, finish assembling some, and then it is no longer on my burden list. Conveyor is a big thing. Testomatic is a big thing. Freetronics wind up is a big thing. Rack 32, OpenKO, adding coming outgoing messages via CAN bus. Okay, I've got to revisit that. But it means that desktop CNC, convert to Linux CNC. I was over at Plasma Steve's factory yesterday and we were talking about that. I'm probably going to do that fairly soon because he's doing a Linux CNC conversion on his big Mazak lathe, which is what I was looking at. So, yeah, that is one thing off the list. Everybody celebrate! Okay, we have one thing off the Project Dopamine list. I should, seriously, I should celebrate. I should go and buy myself a donut or something after the stream. Yeah, that should be a big moment. All right. Scott says John's going to OD on dopamine now. Yeah. All right. Crispian keeps trying to say goodbye, which means it's time for me to go. So, yeah, thank you for coming along to a stream of productivity. This has been a deviation from the norm. This has been a week of productivity and ticking something off the to-do list. Thank you for witnessing this historic occasion, and I will talk to you all after my birthday next week. See you then. Bye.